Hi, I'm Jun Yanose. I'm a master's student at Tokyo Institute of Technology. I'm building a programming environment based on the program design recipe. The program design recipe is a sequence of steps for systematically designing functions. The design recipe is helpful for beginners because it tells them what to do to solve a problem. However, the existing programming environments do not provide enough support for design recipe-based programming. Specifically, there are two problems. First, the student may skip early steps and directly start coding. Second, even if they follow the design recipe, they cannot know whether the outcome of each step is appropriate or not. These are both because some of the intermediate outcomes, such as data definitions and function templates, are not written as runnable code. To solve these problems, we propose to build a hybrid programming environment specialized for running with the design recipe. In our environment, the programmer develops not runnable outcomes using blocks and writes actual code in text. There are several advantages of using a hybrid environment. First, the blocks provide guidance on how to develop intermediate outcomes. Second, the block outcomes allow us to provide feedback on each step. Third, the use of text in the coding step enables smooth transition from our environment to a text-only environment. Let me show you how our environment works. As a demonstration, let us walk through a sample problem. Our goal is to define a function that computes the distance from a given position to origin. In step 1, we define a data structure called poson using block for the define struct. The poson structure has two fields, x and y. So we put two field blocks in the define struct block. So x number and y number. We next create examples of poson. As with Rocket, our environment automatically generates constructor and selector functions, both in the form of blocks. Here, we use a make poson block to create examples of poson. So first example, make poson, for example, number 3 and 4, sorry, 4. And second example, make poson 5, 12. Okay. Having created data examples, we proceed to step 2. In step 2, we write the purpose and signature of the function and develop a function header, again using blocks. The purpose block provides several options of the verb, such as compute, decide, and create. So here, purpose sentence is computes the distance from P to 0. And the signature block has holes for the input type and output type. So here, input type is poson and output type is number. The header block consists of a function name, here distance, to origin and a sequence of inputs. Here, P. And a dummy body. Dummy body is dummy value of output type. So numbers dummy value is 0. After developing these, we go to step 3 and create input-output examples. Remember that the user already developed data examples in step 1. Thus, our environment allows the user to reuse those examples. So, first input-output examples, given make position 3 for expect 5. And second input-output example, given make position 5 and 12, expect 13. Now we move on to step 4. The goal of this step is to develop a template which outlines the structure of the function according to the structure of the input. As in text-based programming, we develop the template by rewriting the function header from step 2. In our example, the input P is a Poisson structure, which has fields X and Y. So we need to extract these fields from P. So we do this by using the Poisson X and the Poisson Y blocks automatically generated by our environment. So placeholder, Poisson X, and Poisson YP. Now we have a template for the function definition, and we can finish up the program by filling the holes. So we go to the text editor. When we are done, we run the tests that we created in step 3. Unfortunately, we haven't been able to support running of programs, but we are going to work on this feature soon. This concludes the demo. Let me switch back to the slide and talk about future work. One thing we are planning to do is to improve the shape and color of blocks. Currently, many of the blocks share the same shape. So the programmer may put a signature block into a long place where we should have an input block. Another piece of our future work is to provide better support for purpose statements. With the current support, we can freely write the purpose sentence. Freedom confuses students in writing correct purpose sentence. We are currently looking at the purpose statements in how to design programs and trying to extract certain patterns from them. And lastly, we want to generate feedback on the block outcomes in each step. For example, when building a template, the programmer may forget to extract a certain field. In such a case, we would like to produce a warning. In summary, we are implementing a hybrid environment that makes students do the informal steps of the design recipe in blocks, and the coding part is done in text. Thank you.